आज ही डाउटनेट ऐप डाउनलोड करें। डाउटनेट पर होगा अब आपके सभी मैथ्स, केमिस्ट्री, फिजिक्स और बायोलॉजी डाउट्स का सफाया। बस अपने क्वेश्चन की फोटो खींचो, उसे क्रॉप करो और तुरंत वीडियो सोल्यूशन पाओ। डाउनलोड नाउ।
Hi friends, the question is explain the following terms: rate of a reaction and activation energy of a reaction. The second question is, that is B, the decomposition of phosphine proceeds according to the following equation. So the equation is given here, and it is found that the reaction follows the following rate equation. Rate is equal to K of phosphine. So the half-life of phosphine is 37.9 at 120 degrees centigrade. How much time is required for 3/4 of phosphine to decompose? And the second question is, what fraction of the original sample of phosphine remains behind after 1 minute? So we have to find two things for the given question B, and we have to explain the term rate of reaction and activation energy of a reaction. So let us discuss it one by one. So solution. So first one is rate of reaction. So rate of reaction is nothing but it actually defined as change in concentration of reactant or product in unit time. So in unit time, there will be a change in concentration of reactant or product, then it is said to be rate of a reaction. Okay, so the rate of a reaction can be defined or stated as change in concentration of reactant or product in unit time. Okay, so in unit time it is said to be rate of reaction. And the second one is activation energy. So the second one is activation energy. So the activation energy. So activation energy is nothing but the minimum extra amount of energy absorbed by the reactant molecule so that the energy becomes to threshold value. Okay, so that is called as activation energy. Threshold value is nothing but the minimum value that threshold value means nothing but the minimum value that reactant needs to proceed the reaction. Okay, so that is called the threshold value, threshold energy. So if the reactant doesn't have the much value, then it should have activation energy. Okay, so the activation energy is nothing but the extra amount of energy absorbed by reactant molecule so that the energy becomes equal to threshold energy. So threshold energy is the required energy that for a reactant to proceed the reaction. If some molecule doesn't have the enough threshold energy, could not reach the threshold energy, then there will be no reaction takes place to give product. So for that purpose, there will be an activation energy. So that will give the extra amount of energy for the reactant to meet the threshold energy. So if it meets the threshold energy, then definitely product will obtain by the result of the reaction takes place. Okay, so threshold energy or value. Okay, so that is called as activation energy. So the activation energy can be denoted like EA. Okay, so EA, it can denoted like EA. Okay, so let's come to the second part. So the decomposition of phosphine. Okay, so let us write the equation first. So 4-phosphine reacts to give phosphorus and 6H2. Okay, so in this for this reaction we have to find the two things. One is the how much time is required for 3/4 of phosphine to decompose, and the other one is the what will be the fraction of sample of phosphine remains behind after 1 minute. Okay, so let us discuss it one by one. So first one, T half, that is half-life I have given that for phosphine is 37.9 second. Okay, So let us take the initial concentration as A. So let us take the initial so let initial concentration of phosphine be A. Okay. A. So therefore X is equal to 3 by 4 A, because we have to find out the 3/4. So 3 by 4 A. Okay. So using the formula, that is T half is equal to 2.303 divided by K log of A divided by, that is concentration initial, and A minus X after a time. So A minus X. Okay. So here T3 by 4 will be, we are going to substitute the values. 2.303 divided by 0.693 divided by T half. Okay. So log of A divided by A minus 3 by 4A. Here K will be equal to 0.693 divided by T half. Okay. So in this way, 2.303 divided by K is nothing but 0.693 divided by T half. Okay. So log of A is 0.693. Okay. Divided by, log of A divided by A minus 3 by 4A. So X is 3 by, so A minus X 3 by 4A. Okay. So when we simplify this, we will get 2.303 into T half divided by 0.693 log of A divided by, when we cross multiply this, there will be 1 by 4A. 4 minus 3, 1, so 1 by 4A. Okay. So then it will like become T is equal to 2.303 into T half, that is T3 by 4. Okay, T3 by 4, because we are finding for the 3 by 4 of phosphine. So 3.03 into T half divided by 0.693 into log of 4. Okay, A and cancel. So log of 4. So then it will become like 2.303 into T half into, we can write log 4 as a 2 log 2 divided by 0.693. So then it becomes like 2.303 into T half have already given, that is 37 point, half-life period is already given 37.9 seconds. Okay. So 37.9 into 2 log 2 is 0.3010. Okay. Divided by 0.693 as T half is equal to 37.9 seconds. Okay. So the next is T3 by 4 is equal to 52. When we simplify the above step, we will get 52.444.693. That will be equal to 75.82 seconds. Okay. So the answer is 75.82 seconds required for 3/4 of the phosphine to decompose. Okay. So therefore 75.82 seconds is required for phosphine, for 3/4 of the phosphine to, decompose. Okay. So this is the answer for the first question in the second part. And then, what fraction of the original sample of phosphine remains behind after 1 minute? So we have to find out after 1 minute. Okay. So let me write here. So here T time, that is equal to after 1 minute. So 1 minute. Okay. So that will be 60 seconds. We can, if it convert into 60 seconds. Okay. Then T half I have already, half-life I have already given, that is like 37.9 seconds. So using the formula, we can write T is equal to 2.303 divided by K log of A0 divided by A T T. Okay, so that is initial divided by after the time. So that is T. The concentration at initial divided by concentration after T. So here let us substitute. Okay, so T is equal to 2.303 divided by K, that is 0.693 divided by T half. Okay, so log of A0 divided by AT, since we know that K is equal to 0.693 divided by T half. Okay, so the next step is T is equal to 2.303 T is equal to 2.303 into T half divided by 0.693 into log of A0 divided by AT. Okay. So now the time I have already given, that is 1 minute as a 60 seconds. So we can substitute T as 60 years. Okay, or 60. So then that will be equal to 2.303 into T half, we know that 37.9 divided by 0.693 into log of concentration at initial divided by after time. Okay, and then 60 is equal to, we have we have found, and then now we have to take this log. So log of A0 divided by AT, that will be equal to 60 into cross multiplied 60 into 0.693 divided by 2.303 into 37.9. So when we simplify this, we will get 47.4768. Okay, 0.4768. So now we have to find this concentration of concentration. Okay, because the final answer is the original, what is the fraction of the original sample of phosphine. So sample of phosphine, so we have to find the concentration. So A, we have to going to take the anti-log. So anti-log of 0.4768 is equal to 2.997. Okay, so we have to find out the sample fraction. So for that, we inverse the T, and below it is initial, that will be equal to 1 divided by 2.997, that will be equal to 0.337. When it is multiplied with 100, then we will get 33.37% of phosphine remain. Okay, after the time 1 minute. Okay, so this is the answer. Thank you.
क्लास 6 से 12 से लेके नीट, IIT, JEE मेंस और एडवांस के लेवल तक 10 मिलियन से ज़्यादा स्टूडेंट्स का भरोसा। आज ही डाउनलोड करें डाउटनट ऐप या व्हाट्सएप कीजिए अपने डाउट्स 8400 400 400 पर।